Okay, so I'm going to do a couple of problems looking at chapter 4, which is where we're going to kind of go back and do a review of problems, but we are going to, let me see if I can figure out how to, there we go, look at factor of safeties. So we have 6 bolts in a connection between the axial member and the support. The ultimate shear strength of the bolts is 300 megapascal. Factor of safety of 4 is required with respect to fracture. Determine the minimum allowable bolt diameter D required to support an applied load. Okay, so the first thing I'm going to do is just kind of set up our equilibrium. And I have the axial member. Okay, and I've got this load P that's being applied of 350 kilonewtons, or 350 times 10 to the third newtons. As I pull, we have an equal and opposite resisting force, and when I look at that force, it's going to be going back across the bolts, and because that's parallel to the surface area, it becomes shear. Okay, so I know that the shear across the bolts is equal to 350 times 10 to the third newtons. Let's look at the bolts then. What is a given? I have 6 of them, and their ultimate is 300 megapascals, which is 300 times 10 to the 6th pascals. I'm going to be using a factor of safety with respect to the ultimate at 4, and we are looking at double shear. So if I look back in this area, I can see there's a bolt area on the front side and the back side of that axial member. Okay, and we want to find diameter. Okay, so what do we know? We know that we're looking at shear, and shear is the same as V over A. Okay, and this shear that we're going to be using, what we're going to be allowed, is going to be the ultimate divided by the factor of safety. So let's look at our allowable. And I have given 300 times 10 to the 6th pascals divided by 4.0. And I'm going to have an allowable shear stress now of 75 times 10 to the 6th pascals. So when I go back and look at my stress equation, I have 75 times 10 to the 6th pascals equals, okay, my shear force that I found using equilibrium is 350 times 10 to the third newtons. And that works out great because we are in Newton per meter squared, divided by area. Well, I have 6 bolts, so I've got 6 times the area. I'm also in double shear, so I have 2 times the area for each bolt. Pi over 4d squared. So here's my equation. Again, this is number of bolts. This is double shear. So I can cross multiply, and I'm going to come up with d squared is 4.9514 times 10 to the negative 4th meters squared. When I take the square root, I get 2.225 times 10 to the negative 2 meters. Well, that's a kind of an odd way to look at the dimensions of a bolt. So we're going to multiply by 1,000 to get rid of the meters and make it millimeters, and we get that the minimum diameter, so it needs to be greater than or equal to 22.25 millimeters. Now again, you probably aren't going to be able to just go into Lowe's or wherever and order something of this size, so you would want to round up and maybe call that 23 millimeters.